Hi, I'm Paul Battaglia, and this is section 1.2. I'm joined today by Gabe and Brittany. Thanks for being here.
Thanks for having me.
Happy to be here.
One of the things that we need to talk about with functions, obviously, is domain and range, specifically domain. And just to kind of start the conversation, I know that when my students come into pre-calc and I ask them what they know about domain and range, their default definition is, well, isn't domain all the x's and isn't range all the y's, right? And I think once we get to this level, we need them to expand that definition a little bit. So, Gabe, I know you have a great analogy.
So students usually have trouble really seeing what domain is, and an analogy that I like to use might be thinking about your function as an oven. So it makes sense to put a tray of cookies in your oven. It makes sense to put a pizza in your oven. So those are two things that we could say are in the domain of our function, the oven. But it might not make sense to put an airplane in an oven, or it might not make sense to put a house in your oven. And those are two things we can say are not in the domain of an oven. Now, is there anything that you might use in your classroom?
With the volume of a sphere, radius can't be negative.
Right, good. That's a good example.
Yeah.
And then also when we're evaluating functions and everything, we want to make sure that we look at domain and range. But doing that with students, I'll do f of 2 and see how they do. And then we'll do f of a, and after one or two problems, they'll do well with that.
Right.
But then f of x plus 2 comes up.
Yeah, I was just going to ask you how they handle that, right?
Yeah.
And things get a little bit troublesome for the students. So what I like to do is replace that x plus 2 with a smiley face.
Oh, that's great. That's a good example. Yeah. Well, it's symbolic, right? I mean, that's all they're doing.
Yeah, so it's like A, but
Right.
they just enjoy it a lot more. So then we do that, and then in the end, we'll input x plus 2.
Okay.
And then I'll show the students that that's what they were doing the whole entire time.
Right.
So, and on that, I kind of, that goes on to the difference quotient.
Oh, good point. Good point.
And Gabe, you have something good for that, right?
Yeah. So difference quotient is something that students really need to understand, especially for calculus. So when it comes time to start learning the definition of the derivative, the difference quotient is huge. So it's something that we need to emphasize whenever we can. And the way that I like to at least introduce the idea is by color coding. So I can either make the x plus h a different color as I'm working through, or I can make the whole f of x plus h a different color.
And
so every
you
time
carry that through the whole example?
So every time I write it down, they can clearly see which part is the f of x plus h, which part is the f of x, and then the whole thing's always divided by h.
See, these are great tips, and I think that the moral of the story for anybody watching is we really need to spend some time on domain. We really do. It's not an easy concept for students to master. They have that all the x's, all the y's level, but we need them to go so much further than that. So maybe one of the things you can do with your class at the end of the section is give them a nice little closing activity. Give them equations such as f of x equals 1 over x plus 4, and then also give them f of x equals 1 over x squared plus 4. And I think what you're looking for here is students who are making the assumption that, on the one hand, x can't be negative 4, and then on the other hand, x can be anything, even though they might think that it can't be, let's say, plus or minus 2. So these are great things to think about as you structure your lesson. I hope these tips have been helpful and that you have much success in section 1.2.